Imagine a device so powerful that it could pull energy seemingly out of thin air, charging itself endlessly without fuel, without solar panels, and without ever needing to be plugged in. A device so extraordinary that rumors claim even Elon Musk himself quietly tested it. But here's the question we all want answered. Is the MSED device a revolutionary leap in clean energy or just another overhyped illusion dressed in scientific mystery? Today, we're diving deep into the claims, the science, the controversy, and the lingering possibility that this could change everything we know about energy. So stay with me, because by the end of this video, you'll decide for yourself. Breakthrough technology or clever marketing. The MSED, short for Magnetic Self-Energizing Device, is said to be a system that generates continuous power using a unique configuration of magnets, coils, and electronic circuitry. Supporters describe it as a self-sustaining energy generator, a concept often dismissed by mainstream science as impossible. After all, physics tells us energy cannot be created from nothing, and yet the demonstrations circulating online showcase devices powering lights, fans, even appliances, without any visible external source. So how does it claim to work? The theory behind MSED revolves around harnessing magnetic resonance and electromagnetic feedback loops, essentially recycling internal energy so efficiently that the input becomes negligible. It's not officially classified as perpetual motion, but it certainly dances on that line. Recently, whispers began circulating in tech circles suggesting that a prototype MSED unit allegedly reached Tesla for private evaluation. Now, let's be clear, Tesla has made no official statement confirming this. However, several insiders and energy bloggers point to indirect signs, like sudden patent interest from major players, discussions in engineering forums, and unusually specific questions raised in EV development threads. Even more intriguing, Elon Musk once said during an interview, "If someone can show me a device that truly outputs more than it takes in, I'll be the first to put it into production." So if he did test it, would he publicly acknowledge it? Or quietly study it until fully verified? Not everyone is convinced. Many engineers argue that the MSED demonstrations lack transparent testing protocols. No peer-reviewed validation. No open schematics shared for replication. Until an accredited laboratory confirms the results, the scientific community will likely remain cautious. But let's entertain the possibility for a moment. What if even a fraction of the claim is true? A device capable of powering homes, vehicles, or entire facilities without fossil fuels, without solar or wind dependency, without grid infrastructure, that would redefine geopolitics, economy, energy accessibility, and even space exploration. Elon Musk's Mars colony would never need fuel shipments, just MSED units. Developing nations could leapfrog decades of infrastructure limitations. Households could become fully energy independent. Is the MSED device a suppressed breakthrough, a misunderstood prototype, or just another viral illusion? And as we peel back more layers surrounding the MSED narrative, it becomes increasingly clear that this conversation is no longer about a single device. It's about a deeper question. Are we, as a society, truly ready to accept a disruptive technology when it doesn't come from an accepted authority? Because history has shown that many groundbreaking inventions were dismissed not for lack of capability, but for arriving too early or from unexpected places. Think of the early electric light, the first wireless transmissions, even the concept of flight. All met with disbelief until proven undeniably real. The MSED device now sits at that same crossroads, hovering between ridicule and reverence, waiting for a moment of undeniable validation. And whether or not Elon Musk has already seen in action, one thing is certain. The idea has reached a point where it cannot simply be ignored. If anything, this controversy is sparking a much-needed shift in public curiosity. People who once never questioned how their energy was produced are suddenly discussing magnetic resonance systems, closed-loop circuitry, voltage feedback harmonics, terms once reserved only for electrical engineers. It's as if the MSED device, real or not, has become a catalyst for awakening intellectual curiosity across the globe. Forums are filling with experimental replicas. Researchers are quietly attempting variations of the design, and small labs in different countries are running silent tests without announcing anything publicly. It almost feels like the beginning of a decentralized scientific movement, not endorsed by institutions, but driven by collective fascination. And in that sense, perhaps the true power of the MSED isn't just in whether it works, but in how it's inspiring thousands to question, explore, and investigate beyond official narratives. So instead of asking only whether the device is real, perhaps the more important question is, what happens if enough people believe it could be? Because belief has a strange way of accelerating innovation. When millions of minds begin pulling in the same direction, engineers, hobbyists, investors, dreamers, something extraordinary often emerges, even if it doesn't look exactly like the original idea. The first prototypes of flight didn't look like modern airplanes. Early computers barely resemble the devices we use today. If the MSED concept is planting the seed of a new kind of energy technology, then even a flawed beginning might evolve into something truly functional with time. And while much of the public discourse remains speculative, there's a quiet but noticeable shift happening in certain engineering communities. Instead of dismissing the concept outright, more professionals are beginning to ask how it might work rather than insisting that it cannot. Small groups of researchers, often working independently and without institutional backing, are now exploring hybrid systems that blend permanent magnet configurations with capacitive energy recovery circuits. Not to defy physics, but to stretch its known boundaries. Some argue that the key may lie not in generating energy from nothing, but in learning to harvest ambient environmental energy so subtly that it appears almost self-sustaining. After all, the Earth itself is surrounded by electromagnetic fields, radio frequencies, static charge in the atmosphere, energy that is present, yet rarely utilized beyond conventional methods. What if devices like the MSED are not violating natural laws at all, but merely tapping into resources that traditional science has overlooked or deemed insignificant? This perspective has led many to reconsider previously discarded inventions throughout history, such as Nikola Tesla's wireless energy experiments and early patents involving rotating magnetic fields that were never fully developed due to lack of funding or interest. Today, with advanced materials, faster circuit processors, and global information sharing, inventions once labeled impractical might now find new life. And perhaps this is why figures like Elon Musk, whether directly involved or not, are always central to discussions like these. Musk represents not just innovation, but permission to think boldly. When his name becomes associated, even through rumor, it signals to the world that the idea is no longer fringe. It is now worthy of attention, and that pursuit is spreading faster than many realize. Educational platforms are beginning to host discussions on magnetic energy feedback systems. Hobbyist kits are being sold quietly through niche channels, allowing curious minds to experiment firsthand. Conferences that once focused solely on solar and wind energy are now expanding their agendas to include emerging unconventional systems, a polite phrase for technologies that are not yet proven but too compelling to ignore. In many ways, the world is preparing itself, not to accept everything blindly, but to evaluate with open curiosity rather than skepticism alone. If such devices were to gain undeniable traction, it's likely that governments and major institutions would respond with a blend of caution, curiosity, and strategy. On one hand, regulatory agencies would seek clarity, requesting performance data, safety assurances, and standardized testing protocols. After all, any technology capable of altering the world's energy infrastructure must be introduced responsibly. On the other hand, nations that rely heavily on fuel exports or centralized power systems might view such advancements as both an opportunity and a disruption. Some may attempt to integrate the technology into their national grid systems. Others may focus on creating private sector partnerships to maintain economic control. Yet there would also be countries, particularly developing nations with limited energy access, that might embrace it with open arms, seeing it not as a threat, but as liberation from decades of infrastructure limitations. But perhaps the most interesting reaction would come from research institutions and universities. Historically, academic circles have been cautious about concepts that fall outside established scientific models. However, progress often begins when observation precedes full understanding. If working prototypes emerge that consistently demonstrated measurable surplus output, even if the precise mechanism wasn't fully understood, the scientific world would eventually adapt its questions rather than dismiss the results. New theoretical frameworks could emerge, not to rewrite physics, but to expand its interpretations. It wouldn't be the first time humanity updated its understanding of natural laws after witnessing consistent results that defied previous assumptions. And amid all of this, the public would play a greater role than ever before. Social media, independent testing channels, and open-source engineering communities have transformed how innovation spread. No longer does a breakthrough require approval from a central authority before it gains global attention. If hundreds or thousands of individuals built and demonstrated functioning replicas, even at small scale, the conversation would no longer be controlled by headlines, but by shared experience. People trust what they can see and verify for themselves. And once a technology crosses that threshold of communal validation, it becomes nearly impossible to contain. Industries like transportation would likely be among the first to undergo transformation if reliable self-sustaining energy systems became viable. Electric vehicles, which today rely on lithium-based batteries and charging networks, could evolve into machines that carry their own continuous power source. Instead of planning routes around charging stations or worrying about range limitations, drivers could experience genuine energy independence. Fleet operators, delivery services, and even rail systems could dramatically reduce operational costs by eliminating fuel logistics entirely. Maritime transport, often dependent on massive diesel engines, might shift towards silent magnetic propulsion systems operating from compact onboard generators. The ripple effect on global shipping lanes alone would be extraordinary. Trading routes could be optimized without concern for fuel resupply hubs. Yet perhaps the most dramatic changes would unfold in aerospace. Aircraft today are constrained by the weight and chemical nature of fuel, but an independent power system would free designers to rethink flight itself. Electric propulsion at high altitudes could become not only feasible but preferable, reducing emissions to near zero while also lowering mechanical complexity. Long-endurance aircraft, capable of staying airborne for days or even weeks, could revolutionize communication, surveillance, and research. And then, beyond Earth, space exploration would enter a golden age. Spacecraft powered by self-sustaining systems would no longer need to carry vast fuel reserves, allowing for lighter, more modular designs. Lunar bases and Martian outposts could operate without constant energy shipments from Earth. Instead of planning missions around fuel limitations, agencies could plan based on ambition alone. But such a shift would raise philosophical questions alongside technological ones. When energy becomes freely available, what becomes a new measure of progress? Industries built on scarcity would need to redefine their relevance. Economies long driven by fuel markets would need to transition toward innovation-driven models. Society would need to rethink responsibility, not just for production, but for stewardship, because while abundant energy could solve many challenges, it could also accelerate misuse if not guided with wisdom and foresight. That is why early discussions, like the one unfolding now around technologies such as the MSED, are so essential. They help shape not only what we build, but how we intend to use it. And so, whether the MSED device proves to be a functional reality or simply a powerful idea that sparks further innovation, its greatest contribution may already be underway. It has rekindled something invaluable, a global sense of wonder. It has reminded scientists, dreamers, engineers, and everyday observers that progress often begins not with certainty, but with curiosity. Even the possibility that such a device could exist has prompted thousands to re-examine what they once believed to be fixed boundaries. If history teaches us anything, it's that some technologies arrive long before they are understood, and some questions remain unanswered until someone is bold enough to explore them without skepticism as the starting point. Perhaps Elon Musk tested such a device. Perhaps he didn't. Perhaps the true breakthrough isn't sitting in a laboratory at all. Perhaps it's taking shape in living rooms, workshops, and student desks across the world right now, quietly, patiently, steadily. Because revolutions rarely announce themselves with fanfare. They begin in whispers, in rumors, in prototypes, in what-ifs. And then one day, without warning, they become reality. So whether the MSED is a monumental leap or merely the spark that leads to the next great invention, one thing is clear. The world is ready. The search will continue. And soon, whether by this device or another, the way we understand energy will never be the same again.